Hello guys, welcome to today's video. Today we are going to talk about probability distributions and its importance in the mathematical foundation. The contents of today's video are the introduction, random variables, sample space, cumulative distributive function, discrete probability distribution, continuous probability distribution, and Poisson distribution. The introduction. This presentation will explore the fundamental concepts and application of probability theory. By examining the fundamental concepts and properties, we aim to provide a deeper understanding of how sample space provides a pivotal role in data analysis, probability theory, and decision-making processes. The meaning of probability is basically the extent so something is likely to happen. Random variables. A random variable represents uncertain quantities and can take on different values with certain probabilities. Understanding random variables is essential in modeling and analyzing random phenomena. In probability, a random variable is a real valued function whose domain is the sample space of the random experiment. It means that each outcome of a random experiment is associated with a real number, and the single real number may vary with the different outcomes of a random experiment. Hence, it is called a random variable, and it is gradually represented by the letter x. Sample space. A sample space is a collection or a set of possible outcomes of a random experiment. The sample space is represented using the symbol S. The subset of possible outcomes of an experiment is called events. A sample space may contain a number of outcomes that depend on the experiment. If it contains a finite number of outcomes, then it is known as discrete or finite sample spaces. Example for sample space. While flipping a coin, two outcomes are possible, such as head and tail. Therefore, the sample space for this experiment is given as S is equal to H, T, which means either head or a tail. When flipping two coins, the number of possible outcomes are four. Let H1 and T1 be the head and tail of the first coin, and H2 and T2 be the head and tail of the second coin, respectively, and the sample space can be written as S is equal to H1, H2, H1, T2, T1, H2, and T1, T2, which means two heads, or a head tail, or a tail head, or two times tails. In general, if you have n coins and the possible number of outcomes will be 2n. Example, if you toss 3 coins, n is taken as 3. Therefore, the possible number of outcomes will be 2 to the power of 3, which is 8 outcomes. Sample space for tossing 3 coins is written as S is equal to 3 times head, 2 times head and a tail, head, head, tail, tail, head, tail, tail, and tail, head. Cumulative distribution function. The cumulative distribution function of a real valued random variable x, evaluated as at x, is the probability function that x will take a value less than or equal to x, used to describe the probability distribution of random variables in a table, and with the help of this data, we can easily create a CDF plot in an Excel sheet. In other words, CDF gives the cumulative probability for the given value. To determine the probability of a random variable, it is used, and also to compare the probability between values under certain conditions. And as for an example for cumulative distribution function, the question reads of f of x is equal to k x squared plus x if 0 is lesser than or equal to x, which is lesser than or equal to 1, or 0 if else. Okay, in this question, we need to prove whether the given function k x squared plus x is in between the interval of 0 and 1. Okay, as per we know that a limit of minus infinity to infinity, f of x here is equal to 1. And by integration, we find out that k x cubed by 3 plus x squared by 2 with the limit is 1 and 0 is equal to 1. Therefore, k 5 by 6 is equal to 1. And therefore, k is equal to 6 by 5. The CDF f of x is a function of PDF, and it can be integrated within the interval minus infinity comma x. If x is the interval of minus infinity x, then f of x is equal to limit minus infinity x f of x dx f x dx. Then f of x is equal to limit of minus x 0 dx f of x is equal to 0. Then if x is an interval of 0 comma 1, then f of x is equal to 0 plus 6 by 5 of x cubed by 3 plus x squared by 2. If x is equal to 1 comma infinity, then we find out that f of x is equal to 0 plus 6 by 5 x cubed by 3 plus x squared by 2, 0 to 1 plus 0 of f of x is equal to x 6 by 5 into 5 by 6 f of x is equal to 1. Therefore, the cumulative distribution function is given by f of x 0 if x is lesser than 0, 6 by 5 by x cubed by 3 plus x squared by 2 if 0 is lesser than or equal to x, which is lesser than or equal to 1, and 1 if x is greater than 1. Discrete probability distribution. Discrete probability distribution is a type of the probability distribution that shows all possible values of a discrete random variable along with the associated probabilities. In other words, a discrete probability distribution gives the likelihood of occurrence of each possible value of a discrete random variable. Geometric distributions, binomial distributions, and Bernoulli distributions are some commonly used discrete probability distributions. And as an example, suppose a fair dice is rolled and then the discrete probability function has to be created. The possible outcomes are 1, 2, 3, 4, 5, and 6. Thus, the total number of outcomes will be 6. All numbers have a fair chance of turning up. This means that the probability of getting any one number is 1 by 6. Using this data, the discrete probability distribution table for a dice can be given as follows. And as you can see, for each of the number, the data will be 1 by 6. Continuous probability distribution. A probability distribution in which the random variable x can take on any value is continuous because there are infinite values that x could assume, and the probability of x taking any one specific value is 0. Therefore, we often speak in ranges of values. P of x is greater than 0 is equal to 0.50. The normal distribution in one example of a continuous distribution. The probability that x falls between two values a and b equals the integral area under the curve from a to b. And according to the formula, we can see that f of x is equal to p. A should be lesser than or equal to x, which also should be lesser than or equal to b, given by limit of a to b. F of x dx should be greater than or equal to 0. Poisson distribution. The Poisson distribution is a discrete probability function that means the variable can take many values in a given list of variable numbers, probably infinite. A Poisson distribution measures how many events an event is likely to occur within X period of time. In other words, we can define this as a probability distribution that results from the Poisson experiment. A Poisson experiment is a statistical experiment that classifies the experiment from two categories, such as success or failure. Poisson distribution is a limiting process of the binomial distribution. Poisson distribution is used under certain conditions, as they are number of trials n tends to infinity, the probability of success p tends to 0, and if np is equal to 1 is finite. And as said per an example, an average of 0.61 soldiers die by horse kicks per year in Prussian army corps. You want to calculate the probability that exactly 2 soldiers died in the 7th Army Corps in 1898, assuming the number of horse kicks per year follows as a Poisson distribution. Okay, then the specific Army Corps and 7th Army Corps and the year 1898 doesn't matter because the probability constants. K will be equal to the deaths of the horse kicks, which is 2, lambda, which will be the 0.1 deaths of horse kicks per year, and E will be 2.718. P of x is equal to K is E to the power of minus lambda and lambda K divided by K epsilon. P is equal to x of 2, x is equal to 2, which will give an ice, and E will be given as 2.718, whereas lambda is 0.61 and 0.61 squared will be divided by 2 epsilon. And by finding the values, 2.718 to the power of minus 2 0.61 can be written as 0.45339, and 0.61 square is equal to 0.3721, and 2 epsilon is 2. So as we divided, p of x is equal to 2, it will be 0.101. The probability that exactly 2 soldiers died in the 7th Army Corps in 1998 is 0.101. Thank you for watching today's video, guys. I do hope you enjoyed the topics.